All right, children, this is the big one. This is the mother of all problems on your tests. You're only going to have one problem like it, and it is the Rocketman problem. So, let's say that I am attached to a jetpack, and I am going to start on a platform that is, let's say it's 3 meters off the ground. Now, I'm going to start from rest, so it's implied that my initial velocity is 0. And let's say this jetpack accelerates me up, let's say 2 meters per second. 2 meters per second squared, excuse me. And let's say that it does this for, let's say, 30 seconds. Okay? Then, much to your displeasure, the jetpack and I become separated. And I then plummet back to the earth. And I don't land back on the platform because it's been moved. I land back on the ground. So, I've got my initial boost phase. I'm like, oh my gosh, this jetpack's so much fun. And then we get detached, and I'm like, oh no. So, what we have to do is first figure out, okay, because I want to know, okay, how high am I going to go before I start falling down? In other words, my max height. So I want to figure out this height. Okay. Now, I actually start 3 meters off the ground, so my y initial is going to be 3. And then I go up. I don't know how far, but I go up for 30 seconds. Okay? So, to find my final speed, I could use our friendly neighborhood v-at. V final equals my v initial plus my acceleration times my time. Now my v initial is 0, so that makes this problem nice because it's just 2 times 30, which is 60. So my v final is 60 meters per second. Okay? Now, it's good that I know my v final, but I also need to know my y final for my boost phase. So, what I need to find, I need to pick an equation that has delta y in it. Well, there's several equations that I could use. I know my v final now, so I could use 1/2 v final plus v initial times my time. I could also use v final squared equals v initial squared plus 2a times my delta y. And one last equation, I could also use delta y equals my v initial times my time plus 1/2 a t squared. Any of those equations would work because I now know v final, I know my v initial, and I know my time. In this equation, again, v final is known, v initial is known, and acceleration is known. Okay? I'm going to choose this one because my v initial is 0, so that goes away. Another way to write delta y is y final minus my y initial is now 3 meters, and that equals 1/2 my acceleration for the boost phase. Remember, I'm still on the boost phase, is 2 meters per second squared, and my time is 30, and that time gets squared. So to find my y final, again, y final minus 3 equals, well, half of 2 is 1, and 30 squared is 900. So 1 times 900 is 900. Add 3, and I get a final height of, good golly, Miss Molly, 903 meters in the air. So that is my y final for my boost phase. At that moment, at that instant, this jetpack separates from me, and I am moving 60 meters per second up. But what changes is now my acceleration is no longer 2 meters per second squared, because now I am in my free fall part. My acceleration now is negative 9.8 meters per second squared. So I'm in a totally separate, I don't know why my tablet's writing at this angle, it's kind of weird. I'm now at a totally separate part of the problem, and this is the free fall section. Because I'm free fall. So I know my y initial for my free fall phase, because my y final for my boost phase was 903. So my y initial is now 903. My y final is what I'm looking for, because I'm looking for the max height. So y initial is 903. Y final, well, I don't know. That's what I'm looking for. I know my acceleration. I know my initial velocity because I found the final velocity for my boost phase. So my initial velocity for my free fall phase becomes 60 meters per second. Now, the last piece of information is my final velocity to get to y final. At the max height, I have a velocity of 0. So I know acceleration, I know my initial and final velocities, but what I don't know is y final, and another thing that I don't know is time. So you should immediately think, oh, I don't know time. I should use the equation that doesn't have time in it. And delta y. Now, v final squared is going to be 0 equals. So now I've got my v initial squared, which is 60 squared, plus 2 times my acceleration, which is negative 9.8, times delta y. I'm going to write it as y final minus my y initial, which is 903. So, to solve for y final, I am going to first subtract 60 squared, which 60 squared is 3600, so I'm going to subtract that to the other side. So I've got negative 3600 equals, I'm going to go ahead and go 2 times negative 9.8, so I got negative 19.6, and then, oops, not equals, let's go ahead and get that erased real quick, like, times y final minus 903. So again, I'm looking for y final. So I'm going to go ahead and divide both sides by negative 19.6. So divide that by negative 19.6, and I get an answer of 183.7 equals y final minus 903. I add 903 to both sides, and holy cow, I am way in the air. 1,806, really 1,807 meters is my max height. Now, what if I asked you how much time I spent in the air from liftoff to splatter? Well, we would again look at it in 2 phases. I would look at my boost phase, and then I would look at my free fall phase. Now, I pretty much know everything about my boost phase because I told you that the boost phase lasted 30 seconds. Hey, that's nice. So now, what I don't know is the time I'm in free fall. Okay? So, I know my V initial for my free fall. It was 60 meters per second. And I know my Y initial, or how high I went up in the air from the beginning part, and it was where? My final height for my boost phase was 903. So this height right here was 903. So my Y initial is 903. Now, my Y final, again, I could do it a couple different ways. I could find the time it takes to get up to the top, and then use that time to figure out how long it takes to get down. Or, I know that my Y final is going to be 0 because I'm starting here and I'm ending up on the ground. And I know my acceleration. It's negative 9.8 meters per second squared. What I don't know is V final as I'm hitting the ground. I don't even want to calculate that right now. I'd imagine it would very much hurt. So I should pick an equation because I'm looking for time. I should pick an equation that doesn't have V final in it. Hey, like this one. Delta Y equals my V initial times time plus 1/2 AT squared. My delta Y, in this case, Y final minus Y initial is going to be negative 903. And that equals, my V initial is 60, and then plus 1/2, my acceleration is negative 9.8, and T is what I'm looking for. So, if this doesn't look familiar, it should. If I add 903 to both sides, I have a quadratic equation. 60t, wow, that's 6, looks awful. There we go, that's a little better. And then I'm going to go ahead and go 1/2 times negative 9.8, or negative 4.9 t squared. So, quadratic formula. T equals negative b, which is going to be negative 60, plus or minus my square root, which is b squared, so that's 3,600, minus 4ac, which is 4 times negative 4.9 times 903, and all of that over 2a, which is 2 times negative 4.9. So, simplifying what's inside the radical first, or what's inside the square root. I have negative 60 plus or minus. So I go 3,600 minus 4 times negative 4.9 times 903, and I get the square root of, oh boy, 21298.8. So 21,298.8 all over 2 times negative 4.9, which is negative 9.8. So doing those operations, if I go negative 60 minus the square root of 21298.8, and then that divided by negative 9.8, hey, I get a positive time, which is 21 seconds. I don't even need to do the other time because I know it's going to be negative. So 21 seconds is how long my free fall phase lasts. That plus 30 seconds lets me know that I was in the air for 51 seconds before I met my unruly demise on the ground. So, this is your rocket problem. Know it and love it.